Welcome to Dr. BT's Chemistry Essentials, A-Level Chemistry made easy. So this is the second video looking at quantification of solutions, and in this video we're going to be focusing on stock solutions and how to deal with questions that involve standard solutions or stock solutions and analysing samples of them and working backwards. Now the next video is then going to be looking at dilutions and the C1V1 equals C2V2 equation. A stock solution is usually contained within a volumetric flask. A volumetric flask is of known volume and will be at usually 250 centimeters cubed. Usually fill up the volumetric flask to the meniscus. When we have this, we call this the stock solution, or sometimes known as the standard solution. In this we have a known volume, the 250 centimeters cubed. I'm going to designate that as a tick because we know it. And then also you would know the concentration. See, with these two pieces of information, you can work out the number of moles of the solute that you have in your standard solution or stock solution. So going forward, let's just put some numbers to this. So we've got our volumetric flask of 250 centimeter cubed, and we make that up with a concentration of 0.1 moles per decimeter cubed. So the number of moles of the solute contained within this solution is going to be the volume times the concentration. Obviously the volume is in centimeter cubed, so there's a mismatch with the units of the concentration. So we're going to first have to just convert 250 into decimeter cubed. To do that, we divide by 1000. There's 0.25 decimeters cubed. This gives us the answer of 0.025 moles. Quite simple. That links nicely with the first video in this series on solutions. However, when doing titrations and other quantitative analysis of solutions, we don't often use the whole solution that's in the standard solution or stock solution. We use a proportion of it. What you would do is use a pipette to take a known volume from the standard solution or the stock solution. Typically this is 25 centimeters cubed, and this is transferred to another container, which is typically a conical flask, certainly in titrations. Whilst the concentration is exactly the same at 0.1 moles per decimeter cubed, volume has evidently changed as we've now only got 25 centimeter cubed sample from that standard solution. So the number of moles that is contained in the conical flask has decreased because the volume has decreased. This is easy to kind of think about when you look at the equation. The number of moles is linked to both volume and concentration. So if one of these terms decreases, and in this situation the volume has decreased, then the number of moles is directly related to this, and so will it also decrease. To work this out again, we need that into decimeter cubed. So our calculation is 0.0025 moles. It's really important when doing quantitative analysis that if you take a sample of a stock solution and you test that particular sample, then when trying to relate this back to what's in the stock solution, you need to know what factor to multiply your number of moles by. Trying to work backwards here, we want to work out the number of moles that we took from our stock solution, but what we do know is the number of moles in our conical flask, known as our sample, and in order to correct this we need to work out the ratio of the volume of the stock solution in relation to the volume of the sample. You'll obviously know these because you've got a fixed volume of the stock solution that's made up in our standard solution, and as I've said before, that's usually 250 centimeter cubed, and then also you would have used a pipette in order to get the fixed volume in your conical flask, which in this case is 25 centimeters cubed. Really, this is just a ratio of the volumes of the two different containers. So let's just imagine that we don't know. We started with 0.025 moles in our stock solution. But what we did do is we tested this sample solution and we worked out that we did have 0.0025 moles. Then what we do know is we know the volume of the conical flask, our sample, is 25 centimeters cubed, as stated here. And we know the volume of our stock solution, as this was 250 centimeters cubed. Now it doesn't really matter what the units are here as long as they match, okay? So you could use the decimeters cubed volume as long as they're both decimeters cubed, or you could use centimeters cubed as long as they're both centimeters cubed. The reason being, this is just looking at the ratios and the differences in magnitude between the two volumes. What we do is we just put this into a calculator. 50 divided by 25 is 10. So we take the 0.025 times that by 10 and we get our answer of the number of moles that were in the stock solution as being 0.025. And so this value matches the value here. So we've shown that this method works consistently. Okay, so let's put this into practice with this question here. So we're going to apply the same 6-step approach to these calculations. So first of all, we're going to box and underline any given values. So boxing, we need to work out how many moles of HCl were in the stock solution. And then having boxed this, we're going to underline the given values. Now with these more complicated calculations where you're dealing with multitude of different solutions, etc., sometimes it's worth sketching out and putting down the information that you've boxed and underlined in a pictorial format. The diagram helps us just visualize what's going on. Then what we're going to do is use our information and apply it to the diagram. Just cross off as you use stuff, just to help really modify your way of thinking. So by drawing a diagram, this helps us to see the relationship between our values. We know that our sample has been taken from our stock solution. We know we've got the number of moles and volume for the sample. We've got the volume for the stock, but we're trying to work out the number of moles of the stock. Now this second bit is to write the equation that links this all together. Now you might see NV and see that you're having to work out concentration as well, so the MVC equation. And you could go down this route. You could work out the concentration of the sample from N and V, and the equation C equals N over V. And then you know that the concentration of the sample and the stock solution or standard solution should be exactly the same. And then you could use those two values once calculated to work out the number of moles of the stock. Or you could use this equation here. We're going to be using this equation here. Rather than just writing that out, I'm just going to put a 2 against here, just to show that's us writing out the equation. Next, we need to check the units of any given values. Obviously, we're just given some volumes, centimeters cubed, and we're given 0.12. Now, if we're using this equation here, we don't need to change the volumes at all because they're both the same units, so we're okay with that. Our next step now is to then rearrange any equations if need be. Now, because we've been asked to work out the number of moles of the stock, and our equation makes that the term, then the rest of the equation is exactly as we need it. So that's this step sorted. Our next step is to substitute in the values into this equation. Now, this is where the diagram really helps you to visualize exactly what's going on. So we're just going to place these values into the correct terms. And then all that remains is to use the equation and calculate it to get the number of moles in our stock solution. So 250 divided by 10 is 25. We're going to times that by 0.12. And so the number of moles in our actual stock solution here was 3 moles. This is really useful whenever you do quantitative analysis, such as a titration on a sample, to then work backwards to work out how many moles were actually in the solution that you were actually analysing. Okay, what I'd like you to do now is to pause the video here and try and do this all on your own, following those 6 steps we looked at earlier and the equation from memory. Okay, if you got the answer that there was 5 moles of sodium carbonate in the stock solution, then well done. We're just going to very quickly go through the fast walkthrough of this question. So we've extracted the information and put it in a user-friendly form in the form of this diagram with labelled annotations. We need the equation. Then we just need to check the units. As stated before, you don't have to go to the effort of changing centimetre cubed into decimetre cubed because we're not comparing it to concentration, which has the units moles per decimeters cubed. So we would have to if we were looking with concentration in mind. But because we're just comparing volume to volume as a ratio, centimetre cubed is absolutely fine. You don't need to rearrange the equation as it's exactly what we need as the term. Just substitute the values that we've extracted from the question. We just put this into a calculator, calculate it, and we work out that 0.3 times 250 divided by 15 is 5 moles. Units are absolutely correct for this question, so we've done that 6th step. Okay, final question here. This is a bit more difficult as it's going to require you to use 2 different equations to work out the answer, but I want you to pause here and have a go at it, and then we'll go through the walkthrough together. Okay, if you got the answer that the mass of the sodium carbonate dissolved was 137.7 grams, then you've calculated the correct answer. Don't worry if you didn't, we're going to quickly work through this and explain exactly how you can get to there. First step, as always, is going to be to box the value we need to calculate and then underline any given values. So the mass of the sodium carbonate in 250 centimetre cube solution is exactly what we're trying to calculate. Our given values are as follows. Then what we need to do is start to look at the equation that links all these together. But before we get to that, let's draw a picture just to help us think. And at this point, let's put our information annotated around this diagram to really start to conceptually understand what's going on in this question. So by doing this, we can start to see for our second step what equations that we need. Now we know if we've got the number of moles and the volume of the sample, we can use that to work out the number of moles of the stock. So the equation for that in here, that then helps us annotate on our diagram that if we can work out the number of moles of stock, have N for the number of moles of stock, and then we've got a link now with number of moles of the stock to the mass of the sodium carbonate that is in the stock solution. And so the equation we need for that is number of moles of the sodium carbonate in the 250 is the mass of the sodium carbonate 250 divided by mR. And obviously what we're trying to work out is this, the mass of the sodium carbonate in 250 centimetre cubed. Do any rearranging, we're just going to check the units are all okay. And because this, again, it doesn't matter as long as both the volumes are exactly the same and the units of those. So we've got centimetre cubed here and centimetre cubed, so that's absolutely fine. Moles is just moles. And then our mass we're going to get in grams, so we can tick that off. Then we start to rearrange. So we've got here mass is exactly what we're trying to work out. So we're going to have to rearrange this equation. And this N here is exactly the same as the N here, sodium carbonate in 250. And we're going to calculate that when we actually use this equation here. So you can start to make links visually about exactly how these are all linking together. All that remains is then we start to put in the different values into our equation. Obviously, the answer to the first equation is then going to allow us to work out the answer to the second equation. But one thing here is we need the MR of sodium carbonate. Using the formula given in the question and a periodic table. It's 105.9 grams per mole. So then what we need to do is calculate our answer of the number of moles of sodium carbonate in our stock solution from the first equation. Use this in our second equation by multiplying by mR, and we'll get our mass. And so calculating this first number of moles in the stock, that's 1.3 moles. So then we can take this, carry this answer down as our term in the second equation. What we do is multiply that by the mR, and we get our mass of 137.7 grams. And there you go, and that's how this 6-step type approach will help you in these sorts of questions. And these sorts of questions are really key in year 2 of the A-level chemistry course, when you start looking at titration data in order to work out the percentage purity of different metals, etc. So getting your head around this now is going to pay dividends in year 2. So this concludes our second video looking at solutions and quantification of those, particularly dealing with taking samples from a stock solution. If you found the video useful, ensure that you like it, and then ensure that you subscribe to the channel for new videos as and when they're uploaded.